guys, so there's been some questions about how to solve some of these equations, so I wanted to go through it with you. So let's see if this will work up here on the board. So the first set of questions ask you to see if 0 was a solution. So what you needed to do was plug 0 into the example. So we would have 4. Now it's not going to write. Oh. So we would have 4, and then 0 instead of x is what you would plug in, plus 2 equals 10. And so when we do that, we can then solve using our order of operations. So 0 plus 2 is 2, so we would have 4 times 2 equals 10. 4 times 2 is 8, and 8 is not equal to 10. So we would say that that is not true. All right, so we're just substituting those in. Going to the next one. We would also plug 0 in for that. And so everywhere we have an x in the equation, you're going to put a 0. So 12 minus 8 times 0 equals 3 times 0 plus 4. And again, you use your order of operations. If you don't remember those, they're parentheses, exponents, multiply or divide left to right, whichever comes first, add or subtract left to right, whichever comes first. All right, so then we've got some multiplication here. Negative 8 times 0 is 0. 12 minus 0 is 12. On this side, 0 plus 4 is 4. And 3 times 4 is 12. So 12 is equal to 12. Realize you can't always see me. There we go. All right. On the next one, we're plugging 0 in again. So 5 times 0 equals 1/2 times 0. And so 5 times 0 is 0. 1/2 times 0 is 0. Any number times 0 is going to be 0. And so 0 is the solution because 0 is equal to 0. All right, this next one was a little tricky. So here, when we plug 0 in, what did you get when you plugged 0 in? 6 divided by 0. You should have gotten an error. So we can't divide anything by 0. You get undefined. Okay, so it is undefined. You cannot divide something by 0. If I have 6 cookies and I try to give them to 0 people, nobody's getting cookies and they're wasted. So you cannot divide by 0. It's undefined. So it is not a solution to this problem. All right, so this next one was talking about the properties that we can do to solve equations and get from one step to another that maintain equality in here. So we have 3x minus 5 equals 16. And if we're solving these, we can rearrange things, and there are things that we can do to keep the equations true. For them to get from equation A to equation B, they simply added 5 to both sides. And so we call this combining like terms. And so if you're moving a term across the equal sign, you have to do the inverse operation. And so 16 plus 5 is 21. So it maintained its equality because we did the correct operation. We couldn't just subtract 5 from 16 because then we would still have a negative 10 on this side, and that would not help us. So if you're moving a term or combining like terms across an equal sign, you have to do the inverse operation. All right, so the next couple of equations, we had a column here, column A, and column B. And it asked you to decide why these two equations were true. So what did they do to get from 16 equals 4 times 9 minus x to 36 minus 4x? So what they did was the distributive property. So the distributive property tells us that if we have a number outside of parentheses here, we're going to distribute it evenly or multiply it by each term. So 4 times 9 gives us 36. 4 times negative x gives us negative 4x. And so that's what they did to maintain equality here. And it was still equal to 16. So they used the distributive property. On the second one, they are not equivalent because they tried to combine like terms like we did a minute ago. However, they did not do it correctly. So when we have 9x equals 5x plus 4, if I want to combine my like terms, they are not on the same side of the equal sign. So I have to do the inverse operation to combine those. And so I would have to subtract 5x from both sides. And I would get 4x equals 4. What they tried to do was say, oh, well, 9x and 5x make 14x. If they were on the same side of the equal sign, we could do that, but they're not, so you can't. So they're not equivalent because they didn't combine terms correctly. All right. The next set of equations, what they tried to do here, we had 5x equals 24 plus 2x. They did combine their like terms correctly when they subtracted 2x from both sides. So subtract 2x from both sides. 5x minus 2x is 3x. Bring down the 24. And so it maintains equality there because they combined like terms correctly by subtracting 2x from both sides. Okay. For the second one, it's a little more tricky here. We have 1/2 x minus 8 equals 9. And so what they tried to do, if you could have figured it out, 9 doubled and 1/2 went away. So they tried to multiply everything by 2. So 2 times 1/2 gives us x, because anytime you're multiplying a fraction by the denominator, it cancels out for you. But what they forgot to do was distribute it to this middle term of -8. So 2 times -8, we should have had -16, and then 2 times 9 gives us 18. So they tried to multiply the equation by 2 to get rid of that fraction, but they left out the -8, and so that messed them up. So remember, when you multiply an equation by something, you have to do it to the entire thing, or it's not going to stay equal. All right, the next set. So these two are still equal. Let's see, they have -3 times 2x plus 9 equals 12. Oops. There we are, that there. Equals 12. And so they got rid of that -3 and 12 became -4. So you might look at this and initially think that you need to use the distributive property and distribute that -3, which is an appropriate move. You could do that, but that's not what they did. Another alternative, this -3 is also implying multiplication with what's in parentheses. So you can undo that by dividing everything by -3. And so that will cancel it out for you. And you're left with what's in parentheses, 2x plus 9. And then 12 divided by -3 gives you -4. So they divided both sides by -3, and that is an appropriate move. Okay. Over here, we have 6x minus 6 equals 3x. And so what they tried to do here was get rid of the 6's by dividing by 6, but they messed up because they only divided one side by 6. When you do something to an equation to keep it equal, what you do to one side, you have to do to the other. So 6x divided by 6 is just x. -6 divided by 6 is 1. And where they messed up, they did not divide the 3x by 6. So you have to do that as well. And 3 divided by 6 becomes 1/2 x. And so that's where they messed up. Anytime you're doing something to one side of the equation, you also have to do it to the other side of the equation. All right. So this one here, maintained equality because all they did was switch it around. And so that's called the commutative property. Anytime you have numbers on the same side of the equal sign, you can rearrange them as long as you don't change their value. So 3 minus x is the same as negative x plus 3. They're just switched around. Okay, and so that's all they did was switch those terms. The second one is not equivalent, and this goes back to what we talked about just a minute ago. We have negative 11 times x minus 2 equals 8. And you can see what they tried to do here was just add 11. So they said, oh, it's minus 11. I can just do the opposite and add 11 to both sides. And if that were negative 11 plus x minus 2, that would work. But since we have that outside parentheses, you would either have to do the distributive property or you can do the opposite and divide by negative 11. But you can't just add 11 to both sides. It doesn't work. It doesn't stay true. So they are not equivalent because they added 11 to both sides instead of dividing by negative 11. All right, and the last one of these, over here, what they did was combined like terms. They had 18 equals 3x minus 6 plus x. So our like terms are the variables here, and 3x and x are on the same side, so we can just do that operation. 3x plus x make 4x, and we still have minus 6 and 18. So they did combine their like terms correctly. For these equations over here, it looks like they did it correctly, almost. They forgot one little thing. So to move this like term 4 to 24, which is the like term because they're both constant, we would subtract 4 from both sides. So they did that correctly, but what they forgot to do was bring this negative sign. So because it is minus 5x, you have to bring that negative down with it. So it should be negative 5x equals 20. And so they left that negative sign off on there. So you have to make sure that when you're solving equations, if you have a minus something after whatever term it is that you're moving, that negative comes, that minus sign comes down as a negative sign and stays with your problem. All right. And so all of those things were explained on this page. So I just showed you what they were saying in these explanations here, because I know that's kind of hard to read through. All right, so on this page, we looked at Noah and how he solved some problems. So you might have gone through here and decided that he did, so it tells you that he thought he made acceptable moves, but ended up with the wrong answer. It wasn't true. So let's look at why it's not true. So he used the commutative property. So what he did was switch the 1 minus 3x into minus 3x plus 1. That is an appropriate move. He did that correctly. Then he combined like terms. So 4x minus 3x becomes 1x. That is also an appropriate move. Then he subtracted x from both sides. So the next step is to combine your like terms. When you do that, if you're adding or subtracting a variable and it cancels out, we no longer have it. So with whatever is left, 6 equals 1 is not a true statement. So he did everything that was acceptable and appropriate. He did the steps correctly, but ended up with a false statement because the two equations aren't true. They're never going to be equivalent. 6 will never be equal to 1. Okay? On the next one, he kind of did the same thing. So this time he applied the distributive property. So 2 times 5 gave him 10. 2 times x was 2x, and that is an appropriate move. He did that correctly. Then he subtracted 10 from both sides. 10 minus 10 cancels out on this side. 9 minus 10 is negative 1. So that is true. Then he added 1 to each side. All right, so let's combine our like terms, add 1 to both sides. That's correct. Then he divided by x. When we're here and we have 2x equals 3x, we don't want to divide because we don't have x by itself yet. So you want to move your like terms over to be next to each other. So we would subtract 2x from both sides, and that would leave you with 0 equals 3 minus 2, which is 1. So here our answer isn't 2 equals 3 and no solution. It is x equals 0. So you can't divide by the variable unless it's the only thing over there. So you want to make sure you combine all of your like terms before you do that. So the first one was no solution, but here we have an answer of x equals 0. All right, so let's look at this one. So what move was made to the original equation to obtain the second equation? And so hopefully you could figure that out based on what we did before. But if we have 5 times x minus 3 equals 5, what could he do to get the second equation? And did he do it correctly? So if I have this, what did I say? So right here, I explained this. So all he did was divide both sides by 5. And so since this is multiplication, 5 times x minus 3, I can undo that multiplication with division. And if you divide both sides by 5, 5 divided by 5 is 1. Those cancel out, and you're left with x minus 3, which was in your parentheses. Okay. The next one, we have 5x minus 3 equals 5. So you're combining like terms. Since it's minus 3, you would add 3 to both sides. And 5 would equal what? Ooh. But they didn't do that correctly, right? And so that's what you had to explain. I was reading that wrong. So anytime, that's a common mistake that y'all make sometimes, is just think, oh, well, it's minus 3, so I'm going to take 3 away from the other side and it'll be equal. But that's not what we do, because that doesn't keep equality. So you have to do it to where it cancels out on that side by adding 3 to both sides instead. And so when we add 3 to both sides, 5 plus 3 is 8. And so 5x equals 8 would still be true with this original equation, because you're just combining your like terms there. All right. So we've got a couple more to look at. So on this one, 5 times x minus 3 equals 5x. What did they do here? Well, in the next slide, I explained to you that they divided both sides by 5 again. And that's a way to undo that multiplication that's being done. So remember, every time what you do to one side, you have to do to the other side. The last one, we have 5 minus 3 times x equals 5x. And so on this one, they divided both sides by x to get all the x's canceled out. This isn't something that we would usually do. We try to get x by itself, so we wouldn't try to get x away, equaling nothing. But that is what they did on this one. Usually we would do the distributive property and then combine our like terms. All right. And then here's some examples that you could have looked at and read through. And so the rest, hopefully you could answer those cool down questions and get your practice problems done. So I do want to let you know that we have 3 grades left for this 9 weeks. So you have this lesson today, lesson 7 practice problem, and you're going to have lesson 8 on your virtual day, which are all virtual already, but there's a virtual day on Saturday. So you have 3 assignments left for this 9 weeks. So if you haven't finished practice problems or anything like that, make sure you get those turned in. They did extend the deadline, so you have through next Friday to get those done. So don't waste your time, use it wisely. and try to keep up more in this next 9 weeks if you kind of got behind this time. All right, hopefully this helps and have a great day.